So welcome to the second week. Today we are going to work on linear regression. If you remember, last time we worked on the scattered plot and correlation. And what we did was we created the scattered plot from the given set of data. And then we say that the scattered plot will give you the pattern or the direction of the relationship between the independent and dependent variable. And then in correlation, we calculated the correlation coefficient R, and that gives you the strength of the relationship between the X and Y variable. We saw that the relationship between the X and Y variable in previous class, that is a linear relationship. And we kind of talk about, we can model such relationship using a line, and that line is called the line of regression, or it is called the line of best fit, or the least square line. And today we are going to find the equation of the line of best fit, which is also called the least square line or line of regression. In general, the equation of the line of regression will be this equation here, which is y hat. You can copy that if you want. Y hat is equal to ax plus b. So y hat, that is the predicted y value, is equal to ax plus b. You can see this is similar to y equal to mx plus b, where a represents the slope and b represents the y-intercept. In order to find the value of a, we use this equation here. And in order to find the value of b, we use this one. You can also write the equation of line of regression like this, which is y hat equal to a times x minus mean of x plus the mean of y. We'll not be using this a lot. Instead, we'll be using the first equation. And in today's example, what we are going to do is we are going to find the equation of line of best fit or the linear regression using calculator. If you want to find without calculator, we find the value of a using this formula, b using that formula, and we can find the equation of line of regression. But today we'll be using calculator to calculate that. Any questions so far? Okay, look like there is no question. We'll go here and we'll talk a little bit more about the line of best fit. If you look at this figure here, you can see these are the points from the scattered plot. Here is one, here is the second one, here is third, here is fourth, here is fifth, here is sixth. And then we have this line here. This line is called the line of best fit. This is your line of best fit. Line of best fit. You can also add this to your note catcher. And then there are a few things that we need to know. The first one is called the residual or errors. So this one is the line which passes through most of the point in the scattered plot, or it will definitely pass through the mean of x and mean of y. But here you can see these values on the line of best fit. These are the predicted value. These are y hat, which is equal to ax plus b. So for each y value, suppose for this one, this is the actual value or the observed value. The predicted value will be on the line. So what I'm saying is, this is the observed value, and the value which will fall on the line, that is called the predicted value. If we find the difference between the observed value and the predicted value, you can see here, d equal to the difference between observed value and the predicted value, that difference is called the residual or errors. So this is the difference between the observed value and the predicted value. Write that formula in your note catcher also. So d equal to y sub 0 minus y hat. That is the difference between the observed value and the predicted value. And this is called the residual or the errors. Now, when we talk about this line of best fit, for the line of best fit, these differences, see, for the first point, difference between y sub 0 and y hat, we say d1. The second is d2. The third is d3. Fourth is d4. Fifth is d5, d6, and it depends on how many points are there. if we square them and add, say for example, first distance is squared, plus second distance is squared, plus third distance is squared, plus fourth distance is squared, plus if you continue like this to all the points, say there are n points squared, n can be 5, n can be 7, n can be 12. If you find all this, and for the line of best fit, for this line, for the regression line or line of best fit, the sum of all these should be minimum. This sum, when you find the value, this S must be minimum. So a regression line, also called the line of best fit, is the line for which the sum of the squares of the residual, this one, sum of the square of the residual is minimum. So because this value should be minimum, this line is also called the least square line. It's just because of that it is also called the least square line. Least square line. So that is the quick introduction to linear regression. We are going to look at the example now. But before we have the example, I have one more slide here where we are going to talk a little bit about two important things that we talked in the previous class also. The first one is outlier, and I told you in the scattered plot, if there is a point which lies quite far from the cluster of the point or quite far from this line, then that's called an outlier. So an outlier in a scattered plot that has the extreme x value or extreme y value, or the extreme both values. In easy way or in simple way, we can say that this is the point which lies far from the cluster of point or line of best fit. And there are some points in the data which are called the influential point. And if you try to remove those influential point, it will make a significant change in the value of R. So sometimes you will see the outlier in the data, and that may be an influential point. Because if you think that that's an outlier and if you try to remove, it will change the value of R. That means the relationship between X and Y variable will change. So we may not be able to remove the outlier easily. So that is the basic concept here. Let's take that example. Here is the first example. In fact, there are several parts on this example. So we are just going to look at a single example with so many parts in it. Are you ready for the example? Yes, no?
Yes.
Yes.
Okay,
Sir.
Yes.
great. Any question?
No.
Not yet.
Nothing so far.
Okay, let's begin this. So what it says is a random sample of 9, what is this? 9 statistics student produced the following data where X is the third exam score. See, this is the third exam score of the 9 students, and their final exam score is also given. So we want to see whether there is a relationship between the third exam score and final exam score. So normally what we think is if somebody is doing well in first, second, and then the third exam also, there are chances that he or she will also do good in the final exam. We are going to observe that in this example. The first part is, you can see, display the data in a scattered plot. So first we need to draw the scattered plot for the given data. So we already learned how to create the scattered plot in previous class. So what I'm going to do is I'm going to wait on you for about 5 minutes, and I want you to create the scattered plot. Please create scattered plot for this given set of data. I'm going to stop recording for now. Once you are done, we'll resume again. Please work on it now. Okay, I hope you tried this. Let's verify together. Are you ready to check your answer?
Yes.
Okay. Okay. So let's check it how the plot will look like. So I just labeled the axis here. I'm going to show you the plot. So along the x-axis, I counted by 2 units. In fact, you can see here is 60 and there is 64. That means 62, 63, 64. So I'm going by 2. And then along the y-axis, I'm counting by 10, starting at 120. That's what I have done. Let's draw the first point. When it is 64, you have 175. 64 is here, and then 175 up there. So 64 and then 175 should be that point. Is that right? Check there. Make sure you verify it correctly. The next is 68. When it is 68, you have 130. So when it is 68, the score is 130. Down here, you can see 68, 130. Then if somebody got 70 in the first exam or third exam, they are getting 185. So 70 and then 185, which is all the way top there. Next one, 71, 160. 71 is a little bit after 70. Okay, and then the final exam score is for 70, it is 160. 71, it is 160. So 160 is there. That's your point. Make sure you verify it. 65, 126. This is 64, 65, 66. So this is your 65. When it is 65, you have 126. When it is 65, you have 126, little bit above 125. That point. You can see it is very scattered. You can clearly see that. 65, 126, 74, 195. When you have 74, it is 195. There is 185 there. 95 should be somewhere up there. Then you have 66, 150. 66 is here. You go to 150, which is up there. So 66 and 150 is that point. Second last point, 71, 160. We already plotted that point. So 71, 160. Somebody got 71 in third exam, 160 in the final. Same with this student also. Last one, we have 70 and 155. When it is 70, it is 155. It is this point. Verify that. Is that how your scatter plot look like? Time for you to speak up.
We did different numbers on X and Y.
That's okay. So based on that, it looks a little bit different. But what I see here is when you look at the general trend, when the X values increases, we can pretty much see that the Y values are also increasing, right?
Yeah.
Do you see my mouse moving through these points, right? And when you look at this cluster of points here, you may say that this point is a little bit far. Maybe that's an outlier. We'll talk about that later on. So your scatter plot should look something similar to this one. So this is your scatter plot. That is the first part of the question. Display the data in a scatter plot. We did that. Now, the next thing is we have to find the correlation coefficient using calculator. So we are going to use calculator and find the correlation coefficient. So I'm going to write here using calculator. You can also write this using calculator R equal to how much? Let's find that. So in order to do that, I am going to share my calculator. So I'm going to stop sharing this. So what you'll do is you'll go to, you can follow along with me, go to stat, and then go to number 1, which says edit. And then in list 1, please enter the third exam score. And in list 2, please enter the final exam score. So now what you'll do is you'll hit this stat. We are calculating the value of R. You have seen this in last class also. Hit stat, then go to calculate. Go to calculate, and then you'll go to number 4, if you remember. You'll go to number 4. And make sure you verify this. We entered the X values in list 1, or the third exam score in list 1. Then the final exam score, or the Y values in list 2. Make sure you check that. We don't have any frequency there. But what I am going to do is, I'm going to store, see, we are asked to store the regression equation. We need that. So you may store the equation. You don't have to, but you can store the equation in Y1. And the way we do this one, please listen to me very carefully and follow along with me. what you'll do is you press alpha. You can see here alpha. Press alpha and then press this trace, which is up here, trace. Then you'll see the list of y values. Select number 1. So 1 is already selected. So just hit enter. So meaning of that is your regression equation is now stored in your calculator. We'll use that later on. Now go down here and calculate. And calculate. What is the value of R? Did we get the same value? Please check it. What is the value of R?
Yes.
0.5223.
Very good. 0.5223. So we get the same answer. So please write that down in your note catcher. So here is my calculator. We have already entered the data. Now what you'll do is you'll go to stat again and then go to calculate. And if you come down here to number 4, we already filled this information. Okay, if you remember here, we did that y1. Okay, we did y1 there and we calculate this. Now see, here is the equation y equal to ax plus b. That is the equation of line of regression. So in place of a, you'll write 3.6831. So you'll write y hat, write down in your note catcher, y hat equal to, in place of a, it is the value of a, which is 3.6831 x. Then the value of b is negative, so it will be minus 93.7610. So that is the equation of line of regression. So it is y equal to ax plus b, plug in the value of a here, plug in the value of b and write it down. Or you can also do this. If you remember, we stored this equation in y1. So you can directly go to y1 and check it. If you hit this y1, please follow along with me. If you hit y1, you'll see that equation here. Look at that, 3.6831x. Then plus and minus, that is minus 93.761. That is your line of regression, which we obtained from the calculator. Do you have any question on how we get the line of regression from calculator?
No, sir.
Okay, great. So we got that equation. This is how we write. The equation of line of regression is y hat equal to ax plus b, which looks like this. So you can see here, you have y equal to, this is your slope, 3.6831, that's your slope, mx, and that's your b. Now what we are asked to do is, we are asked to interpret the slope in the context of the problem. So we need to interpret the meaning of the slope in the context of this problem here. What does that slope mean? So if I go back to the previous slide, and maybe if I try to draw the line of regression there, okay, if I want to draw the line, maybe our line will be something like this. Maybe that is the line of regression. And we got the equation here. And we are just talking about slope here in the part which we are asked to interpret the slope in the context of the problem. So when you think of the slope of any straight line, that is, the slope is equal to change in y divided by change in x. That is the meaning of that. Change in y, when I write delta y, that is change in y, and we divide by change in x, or we say rise over run. So we can just write like this and interpret, or you can go the other way around. You can also do this. You will find the rise, which is delta y, and then run like this, delta x. So either way, you should get the same result, rise over run, because you're dividing this by that or this by this. So the result will be same for the straight line. Now, we need to interpret what is that. So if we want to analyze that over here, you can see that rise in y or change in y over change in x or rise over run is this value, 3.6831. 3.6831. if x equal to, or change in x equal to 1, if change in x equal to 1, if we say that, that is what I'm trying to do is, if I get 65 instead of 64 in the third exam, or in place of 68, if I get 69, in place of 70, if I get 71, that is, if the third exam score increases by 1, what happened here? Let's do that. Then this equation will be delta y, a change in y divided by delta x. I'm considering that as 1. So it will be change in y will be equal to 3.6831. So the meaning is this. The meaning of the slope is, if the third exam score of a student increase by 1, so if they score 1 more point in the third exam, then they will score at least 3.6 points more in the final exam. So this one, see, if they have 68, they are obtaining 130. But if they had 69 in the third exam, they would have 133. We have to add this. They would have 133.6831 in the final exam. That is the meaning of that. So let's write it down. For every increase in third exam score, make sure you write this, third exam score by 1 point, the final exam score will go up by 3.6831 points. That is the interpretation of the slope in the context of the problem. Do you have any question in this example here? Waiting for your answer. Any question in this?
No.
No,
Okay.
sir.
Okay, you can see that the time remaining for this session to end is 4 minutes. So we are going to end the session now. We'll come back after 10 minutes and continue. Is that good?
Yes.
Okay. So here in this part of the example, once we have the equation of line of regression, we are asked to predict the final exam score for a student who received 67 on the third exam. So if you look at the data, we don't have any student who obtained 67. So what we are doing is, if their score was 67, what would be the final exam score? So you know that the third exam score is the X value, final exam score is the Y value. So what we will do is, in this equation, in place of X, we are going to plug in 67, because the third exam score is 67, and we'll predict the final exam score. So let's do that. So Y hat, that is the predicted final exam score, is equal to 3.6831. And here the third exam score is 67. 67 on third exam score. So in place of X, we plug in 67. So 3.6831 times, this is my multiplication sign, times 67. If you don't want to write the multiplication sign like this, you can just do 67 like that. Then minus, the y-intercept is 93.761. 93.761. So please simplify that using calculator. All you have to do is you have to type those values. So type this in your calculator, 3.6831 times 67 minus 93.761, and find out what you will get. Please plug in. Let's see what you will get. If you plug in 67, what did you get? I got 153.0067. You should get that value. Make sure you check it. So what we did is we plug in 67 in place of X, and we got the Y value. So meaning of that is, for a student who obtained, or who might obtain 67 in the third exam, their final exam score would be 153.0067. So we can always use the line of best fit to make the prediction. So you can see that this 67, one thing you have to be very careful here. This 67 is the value which lies in this domain. The domain here for this equation, you can see the minimum value is 64 and the maximum value is 74. And 67 is in between 64 and 74. So we can plug in the value into the equation and we can find the final exam score. Do you have any question on the first part here?
No,
Please
sir.
yourself. No question? Okay. If you have no question on that, look at the second part. Now it is your turn. See, in the second part, we are asked to predict. It's very similar to that question. Predict the final exam score for the student who scored 90 on third exam score. So I'm going to give you a few minutes here to work on that and find the final exam score. It is similar to that. Read the question very nicely, okay? Try to understand what it is asking and then work on it. Please work on that. I'm going to give you a minute or so to work on that. Okay, did we get anything? Or do you have any comment on that? Or you want to share your answer? What do you have? Who got the answer? If you get your answer, please tell me your answer.
237.709.
Okay. Now, look at this one. The final exam is out of 200. Do you think that out of 200, you'll get 237? See, the final exam is out of 200 points, right? So if the exam is out of 200 points, do you think that you'll get 237? Yes or no?
No.
No. So why it is not working? Why do you think? If you plug in, you are getting 237. I already got a comment on why it might not work. What was that comment?
The prediction is not possible.
The prediction is not possible because this 90 is outside the domain of this equation. Okay, because the domain is from 64 up to 74 only. You can plug in any number between 64 and 74 only. You cannot plug in 90. So your answer for this one will not be the math. Instead, it will be a sentence here. Please write this. We cannot make this prediction because x equal to 90 is outside the domain. Outside the domain, not the range. Outside the domain of y hat equal to 3.6831x minus 93.761. Because for this, your x is only x is in between 64 and 74. Minimum is 64 and maximum is 74. So what I wrote here is x lies in this interval from 64 up to 74. So you cannot make the prediction. So always remember, when you're asked to make any prediction in the exam, you must check whether the given value is within the domain of the equation. Then only we can make the prediction. If it is outside, we cannot make any prediction. Any question on this? Yes, no?
No.
No, sir.
Okay. Okay, we'll continue again. We still use the same question. Here is that. I'm going to write that equation on the top. We got the line of regression as y hat equal to 3.6831x minus 93.761. Now, look at this one. The next question we are asked to find is, find the residual for 70. See, for 70 in the problem, you can see for 70, they have 185. And for 70, they have 155. There are two data values there. For 70, it is 185. For 70, it is 155. Two observed values are there. So we'll have two residual also. But if you remember the formula for residual from one of the slides before, the residual D is equal to the observed value minus the predicted value. So first what we are going to do is we are going to find the predicted value for 70. So let's find that predicted value. Predicted value is y hat is equal to, so in order to find the predicted value, 70 lies in the given domain, so we can plug in there 3.6831 times 70 minus 93.761. So please type that in your calculator and check what you'll get by plugging in 70. I got 164.056. I hope you got the same value. Did you get it?
Yeah.
Okay, now let's find the residual. So residual, in order to find residual, we have two observed values, so we'll definitely get two residual. So I'm going to call the first residual as D1 equal to, it is the observed value minus the predicted value. So the observed value is 185 minus the predicted value, which is this one, 164.056. What is that equal to? 185, please do that in your calculator, minus 164.056. What did you get?
20.944.
20.944. That is the difference between the observed value and the predicted value. The observed value is, you can see here, your observed value is higher, it's 185. Predicted value is smaller, so this residual is positive. Let's find the other one, D2. Your observed value for D2 is 155 minus the predicted value is 164.056, which is equal to, so if you subtract that, what did you get? Please use your calculator again and then perform that subtraction. 155 minus 164.056. What is your result?
Negative 9.056.
Negative 9.056. So meaning of that is, see, this value 164 is on the line, okay? 185 is above the line, so the residual is positive. And 155 is below the line because the point on the line is 164, but this is below the line. That's why we got negative. So if you get the residual negative, meaning of that is the observed value is smaller than the predicted value. If you get this residual positive, meaning of that is the observed value is bigger than the residual. That is the meaning of that. So that is at 170. We can go back to the scatter plot and we can check that. So for 70, okay, my line of best fit is not perfect. In fact, it has to pass through somewhere in the middle because I randomly draw that. So 1 point should be above, and you can see for 70, look at that. This point is down here, 1 point is down, the other one is above. So this is your 185. So when you make that subtraction, you got the positive value. The other one is below, so we get negative. Okay, that is the meaning of that. So one more time, if you go back and check here, see, it was 185 and 155. So 185 is this. For 70, 185 is up here. So when you find this difference, you got positive. The other one was 70 and 155. 155 is here. That's why this difference is negative. That is the meaning. Now, in the same question, we are asked to find one more thing. Look at that. Refer back to the scatter plot and find if there are any outliers. So if you go back to the scatter plot, there is that scattered plot. When you look at this scattered plot, do you think that there is any outlier? Outlier is a point that lies far from the cluster of points or the line of best fit. Now, please unmute yourself and tell me if you see any outlier.
64,175.
Right, this point is far from this cluster. So this is your outlier. This is outlier. This is outlier. And this point was 64 and 175. This point, 64, 175. 64, 175. So our answer will be the point, let's write that. The point 64, 175 lies far from the line of best fit. Far from the line of best fit. So it is an outlier. So it is an outlier. Any question there? Yes, no?
No, sir.
No question, okay.